Hello friends, in this video we will talk about development of pituitary and thyroid gland. So let's see how the pituitary gland develops with the applied aspect, how the thyroid gland develops and with the applied aspect. So now first little regarding the introduction gross anatomy. So how we are going to write the answer. First introduction, brief about the gross anatomy and then the development with the developmental disorders. So first introduction, where is this pituitary gland first of all? It's a very small gland which we are seeing in the roof of the third ventricle beside hypothalamic floor. So floor of hypothalamus, below that roof of third ventricle is there. From that we are finding a small gland, that is a pituitary gland. So this is briefly regarding the gross anatomy. Let me explain. So we are having two parts, adeno and neurohypophysis. What is there in adenohypophysis? We have parts tuberalis, intermedia and anterior. Okay, so here please understand that in adeno and neurohypophysis we are having pars anterior. But what is the important difference? In adenohypophysis it's anterior side, in neurohypophysis it is the posterior side. Here we are finding the interglandular cleft which is going to separate adeno and neurohypophysis. This is a stalk-like infundibulum and the median eminence. Here is the hypothalamic floor. Okay. So this is to show you the same thing but in a flow chart. So pituitary gland divided, I said adeno and neurohypophysis. Adenohypophysis divided into three parts, pars anterior, intermedia and tuberalis. Here anterior in the sense anterior side. Okay. Here it will be posterior side in the neurohypophysis. And here we will have the pars nervosa and the infundibulum. Okay. This is a flow chart to show. Now let us see with the development. How does it develop? So we are finding here it is developing from the ectodermal lining. Please remember pituitary gland develops from ectoderm. Okay, that's important. So there is an ectodermal lining which is forming at the roof of the third ventricle as we are seeing, and this develops into Rathke's pouch. This name is important. Rathke's pouch. Here we are having neuroectodermal diverticulum. So this hypothalamic floor is forming into a diverticulum, just like we have a thyroid diverticulum. Okay, like that also here we are seeing the one diverticulum here. So this is the Rathke's pouch. Now this is attached to the stomatodium, so it is going to cut off from the stomatodium here. The diverticulum, there is no change. It will cut off. What is the change? Rathke's pouch will cut off from the stomatodium and then there is a formation of our pituitary gland proper. So this is adenohypophysis, neurohypophysis. Okay. Applied aspect. So any defect in the Rathke's pouch here. As I told you, this is Rathke's pouch. It leads to craniopharyngioma. So let's break the term. Cranio is skull, pharyngeo is the pharyngeal wall, oma is a tumor. So there can be a tumor developing in the skull and the pharynx. That is craniopharyngioma. Now pituitary adenoma is important. So if we recollect the histology, we have alpha, beta and chromophobe cells. Lesion of alpha leads to gigantism and acromegaly. Gigantism, especially in children. Acromegaly, remember letter A for adults. Okay. Now beta cells leads to Cushing syndrome, that is the edema of the head and neck. So here there will be an edema, swelling, Cushing syndrome. And chromophobe leads to bitemporal hemianopia. I explained to you in the AN30.5 competency, that was effect of pituitary tumors in the visual pathway. We had stressed it there regarding the bitemporal hemianopia, but just now we'll recollect. There is a block of the optic chiasma because the pituitary tumor is growing crazy. Okay. Next, regarding the thyroid gland, It is a head shaped gland which is in the anterior neck. So it will be here C5 to T1 vertebra, head shaped gland it is. The same thing I told you, C5 to T1, okay. And here it is a head shaped gland. There is a very special thing, pyramidal lobe, which is attached to our levator glandulae thyroideae muscle. This is the hyoid bone, okay. So brief about the gross anatomy. Important is we are having the lobes, the pyramidal process, the isthmus and the levator glandulae thyroideae muscle. That's important. Let us see the development. So I would like to remind you there is a difference. Pituitary is ectoderm, here thyroid is endoderm. Please remember this difference. Right. So first of all, there is a depression that develops from the endoderm, okay. Then it expands to form the thyroglossal duct. This is important for us. What was important in pituitary? I told you, rat case pouch. Here thyroglossal duct. Then there is a bifurcation. We are observing the bifurcation here, okay. And now this bifurcation is developing into the thyroid gland. Sorry, bifurcation is developing completely into the thyroglossal duct, into the arch we are seeing here. And then there is a formation of the thyroid gland, okay. So this is a sequence to show you the development of the thyroid gland. Now the pathway for the thyroglossal duct, it is starting from where? The pyramidal process. Where is it going up to? If we trace the pathway, it is going up to the foramen cecum. Please remember, thyroid gland develops from foramen cecum, tuberculum impar. Tongue also develops from the same thing, okay. And also there will be hypobranchial eminence, which we will see in the development of the tongue in detail. So this is pathway of thyroglossal duct. Now here we can see the possible locations of the thyroid. Where is the defect? We'll see. Lingual thyroid. Please remember, lingual means tongue, okay. And intra is within the tongue also it can happen. Then supra and infrahyoid thyroid. Suprahyoid, above the hyoid bone, infra is below. That's all. So these four sites are important. Now apart from this, we can have an anomaly of the lobes and shapes. So the isthmus, which is a bridge connecting the two lobes, that isthmus cannot be there. There can be absence of one lobe. There will be both the lobes, but they will be irregular size, in the sense one lobe will be larger, one will be smaller. There can be absence of pyramidal process. The pyramidal process may break up and attach to levator glandulae thyroideae, or it will partially or totally enclose the levator glandulae thyroideae muscle, okay. This is regarding the applied aspect. Now we can also have accessory thyroid, okay. This is nothing but there will be small granules which will be present, but this is incapable to mimic thyroid function. So simple, just remember that there might be accessory thyroid which are very small structures, but these are not very capable enough like the thyroid gland to perform the required functions, like secretion of the hormones, regulating the acid base balance, regulating the calcium levels, okay. This accessory thyroid is not mature or capable enough to perform this function. References from where I took the images. That's it. So thank you so much. I'll see you in the next video.